Welcome to Study Loop.
This is problem 122 of Chapter 7 of Vector Mechanics for Engineers, Statics and Dynamics. So in this problem, there's a cable going from A to E. There's a load applied downward at B of 2 kips, at C of 2 kips, and at D of 2 kips. The horizontal distance from A to B is 6 feet, from B to C is 9 feet, from C to D is 6 feet, and from D to E is 9 feet. The vertical distance from E to A is 7.5 feet. The vertical distance from B to E is distance B, from C to E is distance C, and from D to E is distance D. In the problem, we are given that the distance of C is 5 feet, and we're tasked with finding the distance of B and the distance of D. So we need to solve this problem similar to how we solved problem 119. So we're going to draw a simple beam underneath the forces, and we are going to start with doing the sum of moments around E, setting it equal to 0. This equal negative AY, because it creates a negative moment around E, times 30, because there's 30 meters in the horizontal direction between A and E. We're going to add the force at B, times 24, because 24 meters in the horizontal direction between B and E. Add 2 times 15, 15 meters in the horizontal direction between C and E, and 2 times 9, because 9 meters between D and E in the horizontal direction. So you can go ahead and solve for AY, which equals 3.2 kips. We can do the sum of forces in the y direction set equal to 0. This is AY plus EY, and subtracting all 3 forces. Set equal to 0, we can solve for EY, which equals 2.8 kips. We now are going to solve for the shear forces. Let's start with the shear force of A, which is 3.2, because it only involves AY. Do the shear force of B, which is 3.2, minus the load at B. So subtracting 2 equals 1.2 kips. Shear force at C equals 3.2 minus load at B and minus the load at C equals negative 0.8. Shear force at D equals the same thing, subtracting another load at D, which equals 2.8. And then the shear force at E, which is the same thing as A to D, and then we're going to add 2.8, which is the force EY. So we'll bring it back down to 0. So I'm going to go ahead and graph that. So this is 3.2, and then 1.2. I'm going to go negative for the negative 0.8. And lastly, goes to the negative 2.8, and then back down to 0. Now we're going to calculate the bending moments. So the bending moment at A equals the shear force at A times the distance between A and B, which is 6 feet. Oh, I'm sorry. The bending moment at A starts off to be 0. The bending moment at B is the shear force of A times the distance between A and B, which is 6 feet. This equals 19.2. Shear force at C is the same thing, and then going to add in the shear force at B, which is 1.2, times the distance between B and C, which is 9. And that equals 30. Now the bending moment of D goes 3.2 times 6 plus 1.2 times 9, adding in the negative 0.8, times 6, and this equals 25.2. And lastly, we're going to solve for the bending moment at E, which is the same thing as above, but going to add in the negative 2.8 times 9, and this will bring it back down to 0. So I want to go ahead and graph it up to 19.2, and then up to 30, down a little bit to the 25.2, and then to 0. And that is the bending and shear diagrams. Now back to the main problem. We need to draw a straight line from A to E. So we have a triangle here. We can use Pythagorean theorem to solve for these lengths. So this first length is 6 feet. This length is 3.75 feet. And this length is 2.25 feet using Pythagorean theorem. Now we can start solving for the different distances. So first we're going to start with solving for HC, which is DC minus 3.75. DC was originally given as 15 feet, so we can solve for HC, which is 11.25 feet. We can go ahead and use relationships in geometry. So HB over MB is HC over MC. So we can go ahead and plug in some values. HB over the moment of B, which was 19.2, because HC, which we just saw for, 11.25, over the moment of C, which is 30. So HB equals 7.2 feet. So now we are able to solve for the distance of B. So the distance of B goes 7.2 plus 6, that is 13.2 feet. And that is one solution to this problem. Now we're going to solve for the distance of D. That equals HC over MC is HD over MD. And plugging in values, 11.25 over 30 equals HD over 25.2. So we can solve for HD, which is 9.45 feet. And finally, we can solve for the distance of D, which is 2.25 feet plus HD, which is 9.45, to obtain 11.7 feet for the distance of D. These are the two answers for problem 122.